All right, so we're going to go through some examples for applying the zero exponent rule and the negative exponent rule. So here it is. This is the facts. If you have some number raised to the zero power, it's equal to 1. That's the idea. Now this doesn't apply. I guess I didn't mention that, but this never applies if your base here is actually 0, because 0 to the 0 power, well, that's a total other topic to talk about. And same thing goes for when you have 1 over 0 to any power, really. This would be division by 0, and totally different topic. So uh, this doesn't apply whenever the base is a 0. Just disclaimer there. All right, let's get into some examples. So we want to simplify each of these, and what we need to keep in mind in the back of our mind is PEMDAS. You know how you got to do exponents before you multiply? That's going to come into play here. So 6 to the 0 power, it's easy. It's just 1. All right? It's some number to the 0 power, so it's going to be 1. Nothing to talk about there. All right. The second example, this one's actually going to be 4. The reason why is because you got to do 0 to the 8th power first. So I meant 8 to the 0th power. Sorry, you got to do that first. So this part is equal to 1, but then you're taking that answer and multiplying it by 4. So what you have here is 4 multiplied by 1. And so 4 is our actual answer on that one. All right. For this example, since we're multiplying these two things, we would add those exponents. So 8 plus negative 8, this would give you x to the 0 power. And I just want to mention, this is equal to 1. All right, that's the idea. That's the whole idea behind what we're doing here. All right, the next one. So these two are kind of tricky. You get these confused a lot. It has to do with what all the exponent is applying to. So in this case, the 0 is applying to this entire thing. So you have a whole big expression raised to the 0 power, so it's going to equal 1. The other way that you could think about it is that the 0 gets distributed inside. It applies to both of them. All right, that's the what do they call that? The product? No, it's the power to a power rule, I think, is where we talked about that. But what this is it's 3 to the 0 multiplied by x to the 0, and each of these things are just equal to 1. So you have 1 multiplied by 1, which is 1. Okay. But on this one, the 5x to the 0, this one's actually identical to this problem, the same issue here. So the 0 is only applying to the x in this case. So we have x to the 0, which is equal to 1, and we're multiplying that answer by 5. So 5 times 1, it's going to be 5. Okay? And then the last example here, negative 4 to the 0 power. Again, it gets a little confusing whether we're talking about this versus this, right? Two different things. So you got to know what the exponent is actually applying to. All right, in the top example, the 0 is only applying to the 4, and then we're just adding a negative after the fact, or we're multiplying by negative 1 is what's happening. So 4 to the 0, that's equal to 1, and then we're going to add the negative afterwards. So it's negative 1. But in this example, the 0 does apply to the negative, and it applies to the 4. So if you wanted to write it out in expanded form, you could think of it as negative 1 multiplied by 4, all of that raised to the 0. And so what it ends up looking like is this example up here. The 0 gets distributed across the whole thing. Anyway, For that one, the answer would be positive 1. All right, go back through and kind of check them out again. See if you can make sense for why the answers are the way they are. All right, that's it for our 0 exponent rules. The next video we'll do some of the negative ones.